equilibrium. The first we will start chemical equilibrium. Chemical equilibrium. So first, before going chemical equilibrium, so what is equilibrium? Let us take one chemical reaction. That I'm taking that chemical reaction. I'm taking as here. I'm taking. This is concentration. This is respect to time. Now, I think I can write A, which uses what? B and look at that. First, I'll write it. That's one. Now I can say this is A. This is what B. This is symbol of equilibrium. What is the meaning of this? Look at this. This is the point where that what we can say they attained equilibrium point. Please observe here. What is observation? When the initial time, what do we get? When initial time or the time is equal to 0, the reactant has certain amount of the concentration. When time progresses, what is happening? Obviously, the concentration of A decreases and concentration of B, that means concentration of product is keep on increasing. There is a time. It's called. There is a time. This is the point is called the equilibrium point. The concentration of A and concentration of B remains constant. That means reaction attains equilibrium. Or we can say that the rate of forward reaction is equal to rate of backward reaction is called equilibrium. That means I can write that Kf is equal, I can write is Kb. What is Kf is equal to Kb? Sorry, extremely sorry, not Kf. I can say as Rf is equal to what is that? Rb. What is Rf is equal to Rb? We can say the rate of forward reaction is equal to rate of backward reaction, means reaction attains equilibrium. Or here, look at the graph, what I'm repeating that. At when time is equal to 0, the reactant has certain concentration. When time progresses, the concentration of A decreases. At the same time, the product concentration increases. When the time, that means that they attain the equilibrium, look at this, the concentration of A and concentration of B remains constant. So this is called chemical equilibrium. Now look at this. Now if I want to, as I told you that, let us take one, I'm taking hypothetical reaction. In hypothetical reaction, I'm taking A. This is A stoichiometric coefficient of A. This B is what? Stoichiometric coefficient of B, which gives CC, and I'm writing is what? D. It's a hypothetical reaction. Assume that as a elementary reaction. Now I can take this is A plus B gives C plus D is called a forward reaction. C plus D and gives B plus A is called backward reaction. So now I can write that Rf is equal to, I can write that Kf concentration of A power A. I can write that concentration of B power B by, I can write that Rb is equal to, I can write that Kb concentration of C power C. Concentration of is what? D power D. I write that. So this is rate of forward reaction. This is rate of backward reaction. So once the reaction attains equilibrium, equilibrium means reversible process. So reversible process means what? System and surrounding both are at equilibrium. Now this is the reversible process. That means reversible process means what? The rate of forward reaction is equal to rate of backward reaction. Therefore I can write it. Listen. Rf is equal to what? Rb. Now I can write that Kf A power A, I can write that B power B is equal to, I am writing that Kb C power C, I am writing that B power B. Now I am going to write as Kf by Kb is equal to, I am writing that concentration of C power C, concentration of D power D by, I am writing that concentration of A power A, I am writing that concentration of D power D. Now the ratio of rate constant of forward and rate constant of backward is called equilibrium constant. I can write that K is equal to, I am writing that concentration of C power C, concentration of D power D by, I am writing that concentration of A power A, and concentration of V power V. So this is how we can say we can use here that the equilibrium constant expression. This we can say as a Kc as well as Kp. Kc means what? Equilibrium constant with respect to concentration. Kp means what? Equilibrium constant with respect to partial pressure. Let us take one simple reaction. So we can express that. Kp as well as Kc for both the reaction. Look at this. Now the equilibrium constant can be defined as the ratio of rate constant of forward by rate constant of backward reaction. Now we'll come to the point. Now let us take one simple example. I am taking H2 gas plus what? I2 gas equilibrium to Hi as a gas. Now I want to write Kc. Look at this. Kc means always the product by reactant. Now the equilibrium constant of, I can say, the forward reaction can be expressed as Hi whole square by, I can write that H2, I can write it as what? I2. Now what about in the case of Kp? I can write that Kp is equal to, right, partial pressure of Hi square by, I am writing that partial pressure of H2 into partial pressure of I2. This is how we should express. See, from this we can able to find out what is the unit of equilibrium constant. In this case, we can say the unit of equilibrium constant Kc as well as Kp is what? It's a dimensionless, we can say, no unit. Why? Because this is molar square, this also molar square. This is atmosphere square, this also atmosphere square, both will be cancelled off. So why I am giving reason is there. Now, so what is the relation between Kp as well as Kc? It's very simple. We can write that Kp which is equal to, we can write that Kc RT whole power delta n. So from this, if the delta n means what, we can write delta Ng. That means you should consider delta Ng means what? Number of moles of product minus number of moles of reactants in gaseous state. That's only you should consider. In the case of the equilibrium expression, the pure solids and pure liquid, they're taken as a what? Unity, because they are the concentration of pure solids, the concentration of pure liquids are what we consider as a unity, because they are intensive property. We can say they are intensive. So therefore, the pure solids and the pure liquids in the Kc or Kp expression, they will consider as what we can say unity. So don't forget about it. Now, let us come to the point. In this case, when I am taking as when delta n is equal to 0, we can say that Kp is equal to what? Kc. When delta n is equal to what as positive, we can say that Kp greater than Kc. If delta n is what negative means, we can say that Kp less than Kc. So please, this is the very important. I'll give one simple example, whether it is delta n is negative or positive. Look at that. I'm taking as decomposition of, look at this. I'm taking as decomposition of PCl5. Look at this. I'm taking as PCl5, which is equilibrium, which gives us PCl3 plus Cl2. This is also gas. This also gas. This also gas. Now we can say this is 1 mole. Here also what we can say 1 mole of PCl3. Here also is what? 1 mole of Cl2. So I can say this is 2, 1. So I can write delta Ng. I can write that 2 minus 1 is equal to 1. That means delta Ng is what? Positive in this case. So can we say that Kp greater than Kc? What about in this case? Look at this, N2 plus 3H2 equilibrium, which gives us 2NH3. Now here 1 mole plus 3 mole, that means 4 mole in the reactant side, 2 mole in the product side. So can we say that 2 minus 4 delta N, which is equal to is what? Minus 2. So in this case, what we can say as Kp less than Kc. And what about in this case? We can say H2 plus I2 equilibrium, 2Hi, all are gas. I can say delta N is equal to 0. In this case, Kp is equal to Kc. This is what the first information about that. From this, what type of questions they may ask you in the exam? what type of questions we may expect in the examination. Look at this. They are giving. Now, I'm going to write one question. What is the question is? The Kc of the reaction. The Kc of the reaction. The Kc of the reaction is 300 mole per liter at 300 mole per liter at 27 degrees Celsius. So 300 mole per liter at 27 degrees Celsius. So I'll make it liter per mole and liter per mole is better. Per mole liter at 27 degrees Celsius. Calculate Kp of the reaction. So how to find out it? Here the reaction is not given. Please observe that. Please observe here the unit which gives delta N. I can write this. Liter per mole. And liter per mole means I can say delta N is -1. Delta N is, or we can say as -1. So how we are going to say? Let us take some. How delta N is -1? Let us take it as 2A, which gives B. So writing like this. Now what is Kc expression? Kc is equal to concentration of B. What is that? Concentration of square. That's all. Now this is what we can say molar. This is what we can say that molar square cancelled off. Remaining is what? 1 by molar. So what is 1 by molar means what? 1 by, I can write that mole per liter. So therefore, can we say that here? We can say that if mole per liter, look at this here, liter per mole. Therefore here what is delta N? We can write it as delta N, which is equal to -1. So the unit which gives delta N of the reaction, if they have not provided the what we can say reaction, if they provide reaction, we can easily find out, no problem. Here the equation is not, the reaction is not given. So now you find out that delta N is what? -1. Now you know the relation. What is the relation? I can say that Ap, which is equal to Kc Rp whole power delta N. So what is Kc is given? 300. Am I right? Now what is the R value you are going to use? 0.082. Why? Because Kp means the equilibrium constant with respect to partial pressure. So the unit of pressure is what? Atmosphere. So obviously here you have to use is what? 0.082. And what about temperature is given as 27 degrees Celsius. So you can write as 300 whole power -1. So now I can write as 300 by 0.082 into is what? 300. That's all this, and this will be cancelled out. Therefore, you have 1 by 0.082. If we simplify that, you are going to get the answer of 12.1. 12.1. So, look at this here. Whether answer is right or not, we can easily find out it. Delta N is negative. Therefore, Kp less than Kc. Therefore, our answer is right. This is very simple. Right or not? Very simple. Now, next one. Look at that. Now I want to clean this. Now, next I want to go with that as derivation of what we can say homogeneous equilibrium for the particular reaction. We'll go for Kp as well as Kc. In that, I am going for the delta N is not equal to 0. In that, I am taking as very important, I am taking as a PCl5. PCl5 I am taking as PCl3 plus Cl2 gas. Gas. This is gas. This is gas. Now, when times equal to 0, I am writing is 1 mole. I am taking as a 1 mole of PCl5. This will be 0, and because nothing is formed. We know that you have seen the graph. So obviously what, when time progress, obviously PCl5 decompose will give PCl3 and Cl2. Once the time at equilibrium, we can say that what the reaction attains equilibrium. I can write that T at equilibrium. I'm writing 1 minus x. What is the meaning of 1 minus x? The number of moles of PCl5 unreacted is called 1 minus x mole of PCl5. Here is what, x mole of PCl3, and what we can say, x mole of Cl2, which means that many moles of x mole of PCl3 formed and x mole of Cl2 formed at equilibrium. 1 minus x is nothing but number of moles of PCl5 unreacted. Now what is Kc? We can write Kc is equal to, I can write concentration of PCl3, I can write that concentration of Cl2 by, I'm writing that concentration of PCl5. So what is concentration? We can write it as a N by V, number of moles by volume. So we know number of moles at equilibrium of PCl3 is what, x by V. This also x by V. I'm writing that x by V into x by V by, again I get 1 minus x by V, cancel off. What I am going to get as, very simple, x squared by, I'm writing 1 minus x into V is equal to what we can say, Kc. Now I can write that Kc of this expression, I can write it Kc, yeah, Kc is equal to x squared by 1 minus x into V. Now my question is, because that it will be that, see, at constant temperature, when volume increases, what about Kc? Please keep it in your mind. Kc is equilibrium constant. Equilibrium constant depends on only temperature. When volume increases, Kc remains constant, x is going to increase. Volume increases, Kc remains constant, x means what? I can say that number of moles of, we can say PCl3 and Cl. That means the more amount of, that means PCl3 and Cl2 is going to form. That means equilibrium go towards forward direction. When volume of the container increases, that means volume increases, Kc remains constant. Why? Kc depends on only temperature. Why is that? We'll discuss that. So repeating again, when volume increases, Kc remains constant, x is going to increases. When x increases means what? The degree of dissociation of PCl5 increases. When degree of dissociation of PCl5 increases means what? More amount of PCl3 and Cl2 is going to form. So what about in the case of Kp? Look at that. I am going with that Kp. Same logic. What is Kp? We can say that I can write Kp, which is equal to, we'll write as partial pressure of PCl3. I can write that partial pressure of Cl2 by, I can write that partial pressure of PCl5. So we know the Dalton law of partial pressure. What Dalton law of partial pressure says that, we can say that mole fraction into total pressure. So what is the mole fraction? That means what is the total number of moles in this equilibrium mixture? I can take it. Listen. Now what is total number of moles? I can write 1 minus x plus x is equal to, this will be cancelled off. I can say that 1 plus x is total number of moles at equilibrium. 1 plus x is total number of moles at equilibrium. Now I can go with that Kp, which is equal to, what is partial pressure of PCl3? Partial pressure means what? Mole fraction and total pressure. So what is mole fraction? X by 1 plus x. X by 1 plus x. I can write x by 1 plus x into total pressure of P square by, I can write that 1 minus x by 1 plus x. It will be cancelled off. This and this will be cancelled off. Therefore, x squared 1 plus x into 1 minus x, we can write it as x squared by 1 minus x squared into what? P. Now assume that, let us assume that degree of disturbance in the x is very less than that of unity. So I can neglect that 1 minus x squared is equal to approximately 1. Therefore, I can write it here as Kp is equal to x squared in P. Now, what about, now I can write it, then x is equal to root of, or we can say that Kp by P. So what is the meaning of this? Please keep it in mind. In this equilibrium reaction for decomposition of PCl5, when pressure increases, x is what? Decreases. Kp remains constant. At constant temperature, when pressure increases, x decreases, Kp remains constant for this equilibrium reaction. So this is what that derivation of homogeneous equilibrium. Now the next one. Next is the temperature is dependent on what we can say the equilibrium constant. So what is temperature dependent on equilibrium constant? There is an equation I am going to take it as the Van Hoff equation. I will go with that. d ln k by dt is equal to delta h by r e square. Take. Now what I am going to do is assume that during the temperature, during that short range of temperature, delta h remains constant. I am taking as delta h by r dt by e square. I can take it as d ln k. If we integrate this, what is d ln k? I can take ln k. Ln k is equal to delta h by r. I can write that minus 1 by t. I take it as a plus c. I can write ln k is equal to delta h by r minus 1 by t plus c. This is what we can say the temperature dependent on equilibrium constant. Now if we want to draw the graph means, look at that, I am going with that, very simple. Ln k versus 1 by t. This is what? The slope which you are going to get is what? Minus delta h by r. But this graph belongs to what we can say endothermic reaction. When slope is negative means what we can say endothermic reaction. Why? For endothermic reaction means what? Delta H could be is what? Positive. But in the equation itself we have negative. Therefore the overall you end up with what? Negative. Therefore for the graph that means slope you are getting minus delta H by R means the reaction is for endothermic nature. Now suppose if I am writing as, look at this, ln k versus 1 by t. This is what I am going to get. This belongs to what we can say exothermic reaction. Why? Exothermic reaction means what? Delta H is what? Negative. In this equation itself, we have negative is there. Negative into negative, you end up with is what? Positive. Therefore, the slope you are going to get delta H by R. If the slope is delta H by R, the nature of reaction is what? Exothermic. If the slope is negative means what? The nature of the reaction is what? Endothermic. This is what? Suppose if the two different temperature is given. If the two different temperature, assume that during that short range of temperature, delta H of the process remains constant. Look at that. Now I can write the equation of ln K2 by K1 is equal to delta H by R 1 by T1 minus 1 by T2. Now from this, listen to me. Please keep it in your mind. When temperature increases, if K2 greater than K1, I can say the delta H of the reaction is what? Endothermic. When temperature increases, I can say that K2 less than K1. We can say the delta H of the reaction is what? Exothermic in nature. Don't forget about it. Please keep it in your mind. When temperature increases, when equilibrium constant increases, that means K2 greater than K1, the nature of the reaction is what? Endothermic in nature. When temperature increases, the K2 equilibrium constant decreases means the nature of the reaction is what? Exothermic in nature. Fine. Now come to the point. The next will be, I want to discuss with that some, we can say, good questions. What is the question? We will go with that. And one more thing, before discussing one question, we know that I have written that ln k is equal to minus delta H by RT plus C. So what is the C? You want to find out it. In the morning session, we have discussed thermodynamics. Look at that. Delta G naught is equal to, I can write that, delta H naught minus is what? T delta S naught. Right or not, Cesar? We know that in the equation is delta G is equal to, I can take delta G naught minus plus RT ln Q. This is called the thermodynamic equation. When the reaction attains equilibrium, what we can say? Delta G is equal to 0 at equilibrium Now I can write that delta G naught is equal to minus RT ln K. Once delta G is equal to 0 means Q is equal to K. So now that delta G naught is equal to minus RT ln K, therefore in the place of delta G naught, I can substitute minus RT ln K is equal to delta H naught minus T delta S naught. Now I can write I can write as ln K is equal to minus delta H naught by RT plus delta S naught by R. Look at the comparison. Now you can say that this C is nothing but delta S naught by R, that's called intercept. The slope is what? Delta H naught by R. That means if the minus delta H naught R by is a slope, intercept is delta S naught by R. That's what the graph which I have. Look at this. This is the graph. So I can say that ln K versus 1 by T. So this is what? Intercept. Intercept is what? Delta S naught by R. And slope is what? The slope. That's all. And one more thing, the equilibrium constant is depends on only temperature. It's not depends on the concentration of the reactant and product. Volume. Even if you're going to add addition of catalyst, equilibrium constant is not going to change. We will discuss in the chemical kinetics, not now. So please keep it in your mind. The catalyst, please keep it in your mind. When I'm going to add catalyst, that means equilibrium attains faster. It does not change the what we can say the composition of the equilibrium mixture. It helps to attains faster. The catalyst is a foreign substance. By adding catalyst, it helps to reach equilibrium faster. It does not change the value of what we can say equilibrium constant. It did not change the what we can say the composition of equilibrium mixture. That's a role of catalyst. Now come to the point. Next, I want to discuss one question. Okay, from that info, look at one question. Discuss that. The question is: there is a reaction. I'm writing that N2 plus 3H2 equilibrium 2NH3. That is the question they are given. N2 plus 3H2. N2 plus 3H2 gives 2NH3. They are telling that initial molars, I can say that 1.1. Here is what? 2.2. This will be 0. I'm writing like this. Now the question is, they are telling in a 1 liter container, 1 liter container, in 1 liter, this is the reaction of N2 plus 3H2, 1.1 mole of N2, 2.2 mole of H2 in 1 liter container, and at equilibrium, they are given as 1.2 mole of ammonia is formed. 0.2 mole of NH3 formed. The question is, find out number of moles of H2 at equilibrium. The number of moles of H2 at equilibrium. How to find out it? Listen to me. Write the equation again. I'm writing that N2 plus 3H2 equilibrium, writing as 2NH3. The given initial information is what? When T is equal to 0. Now 1.1 mole of N2. We can write that 2.2 mole of H2. There is no number of moles of ammonia is not found when time is equal to 0. Once time at equilibrium, you can write that 1.1 minus x and write that 2.2 minus 3x, and this is what? 2x. Now what they are telling, this is at equilibrium. The number of moles of ammonia formed at equilibrium is what? 0.2. So we can write it as 2x is equal to, we can write as here 0.2. Now what is that x? X which is equal to 0.2 by 2. We are going to have x which is equal to what? 0.1. X is equal to what? 0.1. This is 2.2 minus 3x is nothing but the number of moles of H2 is unreacted. Therefore, I can write that 2.2 minus 3 into is what? 0.1. Therefore, I can write that 2.2 minus 0.3. So, if you simplify, you may get the answer of is what? 1.9 mole of what we can say H2 is unreacted at equilibrium. This type of question. Repeating the question, there is an equilibrium reaction at what we can say 1 liter container. And please keep it in your mind, equilibrium always takes place only in a closed container. Equilibrium always takes place only in closed container. Equilibrium is always dynamic in nature. That is the properties of equilibrium. Equilibrium may attain either forward or backward direction. That's a general information I want to say. Next question, can we go? Next question is, now I want to give one question. Listen. Now I can say that equilibrium constant of forward reaction and equilibrium constant of backward reaction both are inverse of each other. For example, I will take it. Look at that. Now I am taking one simple reaction. Now I am taking H2 plus I2 equilibrium 2Hi. I am keeping as this is AC. Now I am writing 2Hi equilibrium. I can write as H2 plus I2. Now this is equilibrium constant of forward. This is equilibrium constant of backward. I can write Kc dash is equal to what? 1 by Kc. That means equilibrium constant of forward and equilibrium constant of backward both are is what? Inverse of each other. And one more point, suppose I am taking, look at this, H2 plus I2 equilibrium 2Hi. Let us take Kc which is equal to X. Now I multiply into 2. 2H2 plus 2I2. I can say that equilibrium is what? 4Hi. What is the equilibrium constant of this reaction? Means we can say that Kc dash is equal to what we can say Kc square is equal to what? X square. That means when you are going to what we can say, just if you multiply into 2, right or not, in the reaction, right, in the Kc expression, you should what we can say square of that. Suppose if I'm taking same reaction, H2 plus I2 equilibrium 2Hi, I can say that Kc which is equal to 100. This is equal to is what? 100. Now half H2 plus what we can say half I2 equilibrium, I can say that Hi. What is the equilibrium constant of this reaction? I can say that Kc dash is equal to what? Root Kc is nothing but root 100, and this is what? 10. That means what? When divided by any of equilibrium constant means then divided by 2. That means a new equilibrium constant expression should be what we can say square root. You have to square. That means if you multiply into 2, square. If it is divided by 2, you have to make it as a what? Root of that, square root of that. Divided by 3, cube root. They are able to follow. Now, we will discuss one question based on that. The question is, what they are telling N2 plus 2O2, which you are going to get it as 2NO2. So I can say that Kp of the reaction is what? 100. Find Kp NO2 half O2 plus N2. This is what is given. How to find out this one? Very simple. They are given this is Kp. What is the Kp for this reaction? Observe that the reaction is reverse. At the same time, the reaction is what? Divided by 2. Reverse and divided by 2. That means we can write that Kp dash is equal to The equation is what? Reverse. At the same time, divided by 2, 1 by root Kp or not. Therefore, I can say that Kp dash is equal to 1 by, let's say, root 100, and then what? 1 by 10 is equal to what? 0.1. These type of questions you may expect in the JEE mains point of view. Now look, another important question is that next is the equilibrium constant Kc for the reaction. It's the equilibrium constant Kc. Kc is equal to 16. Kc is equal to 16 for the reaction of SO2 plus NO2. SO2 gas plus NO2 gas equilibrium. I can say that SO3 plus NO all are gas. The question what they are telling that if 1 mole of each, if 1 mole of each, if 1 mole of each, all 4 gases taken in 1 liter, all 4 gases taken in 1 liter container. Okay, find the concentration of NO at equilibrium. This is the question. They gave Kc of the reaction is 60. If 1 mole of each, all 4 gases taken in 1 liter container, what would be the equilibrium concentration of NO? Now look at very carefully. They given when time is equal to 0, very clearly say that look at this 1 mole of each, all 4 gases. That means this is 1, this is 1, this is 1, this is also 1. Now when time is equal to 0, that means 1, 1, 1, and time is equal to equilibrium. We can say that 1 minus x, this is 1 minus x, this is what? 1 plus x, this is what? 1 plus x. Now what Kc? What is Kc expression? Kc, which is equal to, we write concentration of SO3. We can say the concentration of NO by, we can take the concentration of SO2 and we can take concentration of NO2. Now can we say what is concentration of SO3 at equilibrium? 1 plus x, NO also 1 plus x. Anyway, delta n is equal to 0. When delta n equal to 0, volume doesn't matter because volume will be cancelled off. Now I can write it as 1 plus x whole square by, I am writing 1 minus x whole square. So now look at that. Kc is what? 16. Take the root. I can take 4, 1 plus x by 1 minus x. Now if we simplify that, 4 minus 4x is equal to 1 plus x. Therefore we can take it. 3 which is equal to 5x. X is equal to 0.6. They are asking the equilibrium concentration of NO. X value is what? 0.6. Therefore, 1 plus x is the equilibrium concentration of NO. We can say that concentration, please understand, concentration of NO means what? We can write that 1 plus x by V. Here the 1 liter, no problem. If 2 liter given, divided by 2 has to come. So therefore, we can write as 1 plus 0.6 by 1. So answer is 1.6 molar. This is what? This is how you may expect in the JEE mains point of view. This is what in the JEE mains they will ask you. Now, next one. Now, can we go for next question? Will be giving more and more confidence. Look at this. Now, the next question is. I want to write it explain. The question is the vapor density of N2O4 at certain temperature. Vapor density of N2O4 gas at certain temperature is 30 Calculate the percentage dissociation of N2O4. Calculate percentage dissociation of N2O4 at equilibrium. This is the question. So vapor density of N2O4 gas at certain temperature is 30. Calculate the percentage dissociation of N2O4 at equilibrium at certain temperature. Now, what dissociation means, what we can write that N2O4 equilibrium, we can write that 2NO. Let us take for dissociation reaction, I am taking as a, if the number of moles is not given, you take it as a 1 mole initially. When T is equal to 0, take it as a 1 mole. It should be 0. When time is equal to what we can say at equilibrium, write that 1 minus x mole, this should be what 2x mole. What is total number of moles at equilibrium? This is 1 plus x is total number of moles of equilibrium. 1 plus x is total number of moles at equilibrium. Fine. The question starts. Now, how to find out this x value? We know the relation. The relation is what? Listen. Vapor density initial by vapor density at equilibrium. Moles at equilibrium by moles at initial. It's a relation. Don't forget about it. Vapor density initial, vapor density equilibrium. That means the vapor density is inversely proportional to number of moles. So now what is vapor density initial, vapor density equilibrium? They are given at, look at this, the vapor density of N2O4 at certain temperature is that means vapor density at equilibrium is what? 30. I can write that initial is what? N2O4 46 by 30 is equal number of moles at equilibrium is what? 1 plus x by number of moles initial is what? 1. Therefore, if I want to write it as 1 plus x is equal to 46 by 30. Therefore, x is equal to 46 by 30 minus 1. Therefore, if I want to write it as 30, 16 by what is that? 16 by 30. If I simplify that, I am going to get it as 0.533. They are asking percentage multiplied by 100. Therefore, x which is equal to 53.3%. This is the question. Yeah. That's all. Now the another nice question. Look at that. The question is, the next question, as SO2 plus half O2, SO2 gas plus writing is what? Half O2 gas gives what we can say equilibrium as SO3. So delta H which is equal to delta H naught means what? At 298 Kelvin. Value is what? Minus 98.32 kilojoule per mole, and delta S naught which is given as anyway entropy decreases as from negative value only, minus 95 joule per mole, I can say as per Kelvin. The question what they are asking, find the Kp of the reaction. Find Kp. So how to find out it? Very simple. Delta G naught is equal to minus RT ln Kp. So what is delta G naught? We know the relation. We can write that. Delta G naught is equal to my delta H naught minus T delta S naught. What is the delta H naught is given? Minus 98.32 into 10 power 3. Minus temperature is what? Anyway, 298 Kelvin. 298 into delta is what? Minus is there already. Here also minus become plus. Therefore 95. Therefore I am substituting in this equation minus 98.32 into 10 power 3 plus 95 into 298 divided by RT is there. Anyway, Joule 8.314 into 298 is equal to non-K. If we simplify this, that means K, you may get it as, because you are anyway you are going to get it as a what? The overall negative only. Therefore, here also negative is because this 95 to 98, this is 98.3 to 10 power 3. Therefore, this minus and this minus should be cancelled out. Therefore, the equilibrium constant you are going to get it as a, what you can say, positive with a very high value. If you simplify, the value you are going to get as 1.86 into 10 power 12. These type of, look at this thermodynamics linked with the chemical equilibrium. So these type of questions you may expect in the JEE mains point of view. Now, last one, Le-Chatelier principle. What is Le-Chatelier's principle? I can go with that. Le-Chatelier's principle. See, very simple. Whenever the stress is there, so to reduce the stress, equilibrium go towards forward and backward direction. So where more stress, obviously when you are in stress, to reduce stress, you may shout on someone. Same thing in chemical reaction also. In chemical reaction, so what are all the factors which create a stress? Temperature, pressure, concentration, addition of inert gas. Look at this, I am taking one simple example. First I am going with the design. H2 plus I2, I am giving us is what? Here to HI. Now, look at this. Now I am going to add, what we can say, I am going to add H2. When I am going to add H2, the stress is created on, what we can say, reactant side. To reduce the stress, equilibrium go towards forward direction. Or if I keep on removing what? HI, when I keep on removing HI, so stress on the reactant side, therefore the equilibrium go towards the forward direction. Whether addition of reactant or the removal of product, reaction go towards forward direction. Or addition of product or removal of reactant, it goes towards, what we can say, backward direction. That means the concentration, addition of H2 or addition of I2, equilibrium go towards forward, or addition of HI or increase the concentration of HI or decrease the concentration of H2 or I2, equilibrium go towards backward direction. What about equilibrium constant? Remains same, because equilibrium constant is not depends on the concentration of reacting species. Alright? And next will be very important in the case of pressure only more important. Look at this. Now let us take, I will take the one important thing. I am taking as PCl5 equilibrium. Can take it as a what? PCl3 plus is what? Cl2. This is one. Okay, all are gas. I am taking is N2 plus 3H2. I can say that equilibrium 2NH2. Last will be is what? H2 I2 equilibrium 2H2. So there are three cases I am taking in the case of pressure. Listen to me. We know that very simple. You can explain this on the equation, but I will give simple idea. In these three cases, I am taking first case. When I increase pressure, what will happen? When I increase pressure, obviously what is going to happen? Volume decreases. When volume decreases means what? Number of moles per unit volume is going to increases. Number of moles per unit volume increases, which means that wherever the more number of moles is there the equilibrium, that is stress created. To reduce the stress, wherever the less number of moles, their equilibrium will shift. That means on increasing pressure, where less number of moles, their equilibrium will shift. Now I can say, here I can say 1 mole, here I can say is what? 2 mole. So when I increase pressure, equilibrium go towards backward. Look at in this case, I can say as here 4 mole, here is what? 2 mole. On increased pressure, equilibrium go towards as a forward. But in this case, here also 2 mole, here also is what? 2 mole. Therefore, When I increase pressure or decrease pressure, equilibrium, nothing is going to affect. Equilibrium remains same because equilibrium is not going to affect it when delta n is equal to 0. Why? I told you here, if I had Kc expression, Kc is equal to, I'm going to get is what? 4x squared by 1 minus x whole squared. Because in this term, there is no pressure term, there is no volume term. Therefore, this reaction is independent of pressure and volume when delta n equal to 0. But these two are dependent. This equation already I told you. What is that? Look at this. When Kc is equal to x squared by 1 minus x into what? V. When pressure increases, what is going to happen? Volume decreases. When volume decreases, obviously what? Kc remains constant and x decreases. X decreases means what? The less amount of PCl3 and Cl, therefore equilibrium go towards backward direction. That's all I told you. Simple logic. What? Take it when increasing pressure. In equilibrium should be all or should be gas. Keep it in your mind. Where the less number of moles is there, equilibrium will go. That's all. When delta n equal to 0, no problem. Suppose if, what about in this case? Suppose what about temperature? Very simple. Listen. Now let us take that N2O4 gas. Equilibrium is what? 2NO2. Now I can say this is endo, this is what as exothermic. Listen, the nature of the reaction, they will give delta H. See, I can say that delta H is equal to positive. Now I can say for formation of NO2, it's a endothermic in nature. Please keep it in your mind. Therefore, forward is endo, backward is what? Exo. If I increase temperature, the stress on the reactant side, equilibrium go towards forward direction. When increase temperature, more amount of NO2 is formed. When decrease temperature, equilibrium go towards backward direction. What about the equilibrium constant? It changes. Why? Equilibrium constant depends on temperature. Suppose if I am taking, look at this, N2 plus 3H2, equilibrium 2NH3, I can write that delta H is what? Negative. That means forward is XO and backward is what? Endo. That means when decreased temperature, stress on the reactant side, cooling. Therefore, the equilibrium go towards what we can say forward direction. On heating, so decomposition takes place because obviously what? The stress on the product side, equilibrium go towards backward direction. What about equilibrium constant? Changes. But in exam, what they will ask you? Look at that. Just I'll give one simple example. Just I'll take it. Let us take the example of is what? PCl5 is what we can say. PCl3 plus gas. Listen, what are all the favorable conditions to get the more yield of PCl3 and Cl2? Very simple. So I want to get this is what? Decomposition reaction. Decomposition reaction means what? I have to supply the energy. So therefore, one condition is increasing temperature, which gives the more amount of PCl3 and Cl2. At the same time, if I decrease pressure, when I decrease pressure, I'm going to get more amount of PCl3 and Cl2. Such questions you may expect in the exam. And another important point, look at this. Now, I'm taking, as look at this, NaNO3 solid, which gives NaNO2 also solid, plus what? Half O2 gas. Please understand, this is very important. Now, what I am asking, addition of NaNO3, the question I'm asking you, you should answer that. Addition of NaNO3, equilibrium go towards forward direction. I can say the statement is incorrect. Why? You are adding solid. Because in equilibrium expression, whether it is Kc, you are going to have is what? O2 whole power 1 by 2, or you can write Kp is equal to partial pressure of O2. This only you are going to get it. Because in equilibrium constant expression, you are not going to get solid. The pure solids are considered as a what? Unity. So now if I am going to add NaNO3, now if I am going to add NaNO2, what will happen? Nothing is going to happen. Equilibrium is remained same. But if I increase temperature, because decomposition reaction, increase temperature, equilibrium go towards the forward direction. Increase pressure, here less number of moles, equilibrium go towards the backward direction. right or not? But addition of solids to this reaction, nothing is going to happen. So what about the inert gas? It's very important. Look at this. I'm taking inert gas. The inert gas one will be at constant pressure. Another one is what? Constant volume. Look at this. Addition of inert gas. Addition of inert gas at constant temperature, and one is constant pressure, another one is constant volume. I'm taking two cases. Look at this. I'm taking as H2 plus I2 equilibrium to Hi. So therefore I can take Kc is equal to 4x squared by 1 minus x whole square. Look at this. In this one, if I'm going to anyway, we can say at constant pressure and constant temperature. When I'm going to add what as neon as inert gas, obviously what is going to happen? The number of moles increases. The number of moles increases means what? The total volume of the system is going to increase. That means I can say volume increases for this one. Why? PV equal to nRT. Am I right or not? Therefore, N directly proportional to V. Therefore, the total volume of system increases by addition of inert gas at constant pressure, constant temperature. So now look at this equation. There is no volume term is involved. Therefore, addition of inert gas at constant pressure, if delta N is equal to 0, there is no effect on equilibrium. There is no effect on equilibrium. Suppose, look at this, if I am taking PCl5, equilibrium, I can take it as PCl3 plus Cl2. Look at that, I am taking Kc is equal to x squared by 1 minus x into V. Look at these cases. In this, if I am going to add as what? Neon, same logic. Volume increases, volume term is there. Therefore, this is depends on the volume. Volume increases, Kc remains constant. X is going to increases. That means the more amount of PCl3 and Cl2 is going to form. That means we can conclude that addition of inert gas at constant pressure, if delta N is not equal to 0, the wherever the more number of moles is there, their equilibrium will shift. Repeating again, the addition of inert gas at constant pressure, therefore total volume increases. If delta N is equal to 0, no change in equilibrium. But if delta N is not equal to 0, look at this, we can say that when addition of inert gas at constant pressure, so the volume of system increases. When volume increases, Kc remains constant, therefore X is going to increase. When X increases means what? The more amount of PCl3 and Cl2 is going to increase. That means, so addition of inert gas at constant pressure, at constant temperature, if delta N is not equal to 0, the where the more number of moles is there, their equilibrium will shift. Now come to the point of addition of inert gas at constant volume. Same case I am taking, look at that. H2 plus I2 equilibrium is what? To Hi. So therefore here Kc's expression is what? 4x squared by 1 minus x to the power of x whole square. So now here also there is no volume term is not involved. So obviously what? When volume term, pressure term. Now look at this. If I am going to add addition of inert gas at constant volume, at constant temperature, what is going to happen? Total pressure of the system increases. Keep in mind, total pressure increases, but partial pressure of the individual gases remains same. Therefore, here anyway the pressure term is not involved. Therefore, the equilibrium is not going to be affected. Suppose in this case I am taking as PCl5 equilibrium as PCl3 plus Cl2. I can write that Kp is equal to partial pressure of PCl3 and take that partial pressure of Cl2 by we can say that partial pressure of PCl5. So anyway that partial pressure of PCl3, partial Cl2 and partial pressure of PCl5 remains same. Only total pressure going to increase. You may ask the question, can you sir partial pressure nothing but mole fraction total pressure. So when I'm going to add, mole fraction also will change, total pressure also will change, therefore partial pressure remains same. Obviously what is going to happen? The equilibrium is not going to affect that. Now I can say the addition of inert gas at constant volume, whether delta N equal to 0 or delta N is not equal to 0, equilibrium, nothing will happen. It remains same. But here, addition of inert gas at constant pressure, if delta N equal to 0, equilibrium remains same. But delta N is not equal to 0 means wherever the more number of moles is there, their equilibrium will shift. That's all. This is about what we can say chemical equilibrium. Now we will move towards the ionic equilibrium. Come to the point. Ionic equilibrium. Now, this in ionic equilibrium, what all we are going to learn? I will go with that strong acids and weak acid. That means I can write that pH of strong acid, weak base, and strong base. Over. Next is pH. Over. Now we can go with the buffer solution. The next will be hydrolysis of salts. Hydrolysis of salt. And last will be is what? Solubility product. So now we want to know what is strong acid, what is weak acid, what is strong base and weak base. See, if it is acid means any substance which gives H plus ion is called acid. What is base? Any substance except H plus ion is called base as per the Bronsted-Lowry acid base concept. Any substance gives H plus ion in solution. Any substance gives OH minus ion solution also is called base. Any substance except H plus ion is called base. Any substance gives H plus ion is called acid. That's a basic thing. Now, we want to find out what is the strong acid and weak acid. Strong acid means what? They dissociate completely. They give 100% H plus ion in solution. What is the weak acid? They never dissociate completely into water. They are partially dissociated. Same thing for weak base and strong base. Strong base dissociate completely. Weak base they never dissociate completely. Look at that. Now I am going with that. And I am taking, listen, we know that H2O. We can write it as H plus plus OH minus. Writing. Now this is nothing but K is equal to concentration of H plus ion as well as that OH minus, and I can write it. Now this is what? K, I can write KW. Now they are finding out experimentally the H plus ion concentration at 25 degrees Celsius is what? 10 power minus 7 molar. Now if I am saying water means water for any temperature. If I am saying water means concentration of H plus ion is equal to concentration of OH minus ion. Therefore I can write KW is equal to H plus whole square. Therefore 10 power minus 7 whole square. Therefore KW is equal to what? 10 power minus 14. That means water. If I am saying water means concentration of H plus ion is equal to concentration of OH minus ion. They are finding out at 25 degrees Celsius the concentration of H plus is 10 power minus 7. Therefore this is a water. Therefore concentration of H plus equal to concentration of OH minus ion. Therefore KW is equal to 10 power minus 14 at 25 degrees Celsius. Because it's equilibrium constant. So the equilibrium constant depends on temperature. I can say at 25 degrees Celsius. Now look at this. Now this one. Please take the negative logarithm both the sides. I can take it as minus log of H plus minus log of OH minus. What is KW? We know that minus log of 10 power minus 14. What is minus log of H plus? We can say as pH. What is minus log of OH minus plus POH is equal to 14 at 25 degrees Celsius. Please keep it in your mind. pH plus POH equal to 14 at 25 degrees Celsius, not for all temperature. Why? Because KW is equilibrium constant, depends on temperature. When temperature increases, KW will increase. When KW increase, pH will decrease. When temperature increases, KW will increase, pH is going to decrease. At 25 degrees Celsius, we can say neutral means pH equal to 7. pH equal to only we can say 7. If it is pH is less than 7 means what we can say acidic nature. pH is greater than 7 means what? It's a basic nature. That's what they will say. When H plus ion concentration greater than OH minus ion concentration, the solution is acidic. If the H plus ion concentration is less than OH minus ion concentration, solution is basic. When H plus ion concentration is equal to OH minus ion concentration, solution is what? Neutral. So at 25 degrees Celsius, pH plus pOH equal to 14, we can say. Now, what in exam they will ask you, look at this. They may say pH of water is 5 at 60 degrees Celsius. Kw is equal to what? 10 power minus 12 at 60 degrees Celsius. Find out whether the water is acidic or basic or neutral. Find whether this at pH equal to 5, whether it is acidic or basic or neutral. That's what they will ask you. Look at that. Now what I am going to do, in this case, here Kw is given. Here water. Water means what? Concentration of H plus ion is equal to what? Concentration of OH minus ion for any water. Now, therefore I can write that Kw, we know that Kw is equal to H plus and OH minus. What is Kw? 10 power minus 12. So H plus into OH minus is what I can write as H plus whole square. Water means is the condition. Therefore what? H plus is nothing but 10 power minus 6. Alright or not? That means in this case we can write it as pH plus pOH is equal to, we can say as 12. In this case, if pH equal to 6, solution is neutral. So less than 6, acidic, greater than 6 is basic. Now what is given? They given us a 5. They given is what? 5. That's all. This is what in the examination point of view they will ask you. See, even I can say from my side, they may see, they gave that the pH of water is 5 at what is 60 degrees Celsius. They may ask you to find out delta G naught. Look at this. See, I given pH of water is 5 at what we can say that at 60 degrees Celsius. Find what we can say. Find delta G naught at what we can say 60 degrees Celsius. Okay. Rather than 60, we will make it as, okay, I'll make one question. Listen, I'll make it as 2H2O. I can say that H3O plus plus what we can say that OH minus. Now I can say that pH of the above reaction is 5 at 500 Kelvin. Calculate delta G naught. This is what you may expect the question. See, this is the water. Water means what we can say? Concentration of H plus ion is equal to what? Concentration of OH minus ion, we can say that. Alright. Now evaluate equilibrium. Equilibrium means what we can say? Delta G is equal to delta G naught plus RT ln K. Therefore, we can say delta G is equal to 0 for equilibrium. We can write that delta G naught is equal to minus RT ln, I'm writing as a KW. Right. Now look at this, I am asking delta G naught. Now temperature is given as what? As a 500. Right. Now look at that. I am writing as delta G naught minus express in terms of kilocalories. So when kilocalories means what? R value you are going to take it as a what? 2. Temperature is what? As 500 into I am converting ln to log. Log Kw. Now we know that this is pH equal to 5. Don't forget about it. That means H plus is equal to OH minus. Therefore H plus is 10 power minus 5. Therefore you are going to write H plus whole squared is equal to kW or not. Therefore 10 power minus 5 whole squared is equal to kW. Therefore I can substitute that minus 2 into 500. I can write that 2.303 log of 10 power minus 10. Right? Therefore here minus, obviously minus, you may write as 1000 into 2.303 into 10. That means you can add it as 2.303 into what? 10 power 4 calories is the answer. That's all how it is linked. This is what the question. Now next one. So can we say this? Now we can say that pH is equal to minus log of H plus. Now my question is, I am taking HCl. I can say 10 power minus 3 molar, 10 power minus 5 molar, 10 power minus 7 molar. What is the pH? So 10 power minus 3 molar, 10 power minus 5 molar, and 10 power minus, what do we can say? Minus, can you say when HCl at 25 degrees Celsius, aqueous HCl, and one more thing, pH is only applicable to dilute solutions better, not more, because they have to give H plus here, right or not? Now, you can say that here pH is equal to 3, here pH is equal to 5. Can we write? That means the pH of 10 power minus 7 molar of hydrochloric acid is 7. Can we make statement is right? No, it's incorrect statement. We cannot say that because you keep on adding water. The acidic nature of HCl, how it become neutral by adding water? Impossible. So whatever will be the dilution, the acidic nature of, that means the acidic nature of HCl is always, what we can say, less than 7. Whatever it may be dilution. Alright. Then how to find out the pH of 10 power minus 7 molar of hydrochloric acid? Very simple. I'm taking HCl. There are two possibilities. It is in aqueous. This is aqueous. Therefore, H plus coming from acid. Here what? H plus coming from water. Even we can say that water also gives H plus here. See, till 10 power minus 6 molar of hydrochloric acid, the whatever H plus and coming from water is neglected. So once 10 power minus molar comes, we should include the H plus and coming from water also. We should more dilution. We should consider that. So this is also 10 power minus 7. This is also 10 power minus 7. Total is what? 2 into 10 power minus 7. So therefore, what we can write? pH is equal to minus log of H plus. So minus log of 2 into 10 power minus 7. Therefore, log 2 is what? 0.3. We can say 7 minus 0.3 is what? 6.7. So the pH of 10 power minus 7 molar of hydrochloric acid less than, even 10 power minus 8 molar less than 7. 10 power minus 9 less than 7. So the whatever it may be dilution, the pH of the acid is always, what we can say, is less than 7. pH of base also is greater than 7 at 25 degrees Celsius. Fine. The next one. Look at that. I want to say that. Next will be. Next. I'm going with that. HCl, CH3, C over H. We can say that 10 power minus 3 molar. This also I can say is what? 10 power minus 3 molar. Look at this. Can we say both will have same pH? I can say no. Why? Because hydrochloric acid is strong acid. This is weak acid. So weak acid never dissociate completely. Therefore, we cannot say that the both have same concentration. So we cannot conclude that both can have what we same pH, because acidic acid is what? Weak acid. When acidic acid is weak acid, so what we have to look at that. Now we want to find out derivation. We have to do. Look at this. Now I'm taking as acidic acid CH3, C double bond O, OH. I can say that equilibrium CH3, C double bond O as O minus plus H plus. Let us take when T is equal to 0. This is some concentration. So it is 0 and 0. Now at equilibrium, I can say that C minus C alpha. This is what? C alpha. This is what? C alpha. Now what is K? K is equal to, you can write that C square, alpha square, C into 1 minus alpha, alpha cancelled off. Now you are having that C alpha squared by 1 minus alpha. Assume that alpha is less than what we can say, very less than 1. Therefore, the 1 minus alpha is equal to 1 we can consider. Therefore, we can write that C alpha squared. Here K, I am making is what Ka. So, why is here Ka? Please keep it in your mind. This is acid dissociation constant. Therefore, I can say that Ka is equal to C alpha squared. Therefore, alpha is equal to root of Ka by C. Now, please understand, here this is concentration. On dilution increases. What is the meaning of dilution increases? Concentration decreases. On dilution increases, alpha increases, Ka remains constant. Why? Ka is what? Equilibrium constant. Therefore, alpha is equal to root of Ka by C. From this, look at that. Now, I want to find out pH. Now, what I can say? In this, I want to multiply both the sides what? Concentration. C alpha is equal to root of Ka into C. So what is C alpha? C alpha H plus. I can write that concentration of H plus ion is equal to root of Ka into C. Take the negative logarithm of both the sides. Therefore, we can write pH is equal to 1 by 2 pKa minus log C. This is what we can say the equation of we can say weak acid pH equal to 1 by 2 pKa minus log C. Look at this. On dilution, pH will change, pKa remains constant. For dilution of weak acid, concentration means what? Dilution, concentration will change, pH will change, pKa remains constant. So now we'll go one question, very simple question. Look at this. Now, let us take and making. Calculate pH of 10 power minus 2 molar of CH3COOH at 25 degrees Celsius. pK is equal to 4.74. 10 power minus 2 molar pH. We just now have done the equation. pH is equal to 1 by 2 pKa minus C. Now what is that? 1 by 2 pK is what? 4.74 minus log is what? As 10 power minus 2. Now 4.74 plus 2 by. This is the answer. That's all. This is the pH. But question is, what about the alpha? What the alpha? Look at this. Now, I want to clean this. Look at this. I'm cleaning. What about the alpha? See, I'm telling this Ka of the acid. You take it as a what? 2 into 10 power minus 5. You take it. That's a Ka of the acid. Therefore, we can say that Ka is equal to C alpha squared. Alpha is equal to root of Ka by C. What is Ka? We can write it as 2 into 10 power minus 5 by, we can say that 10 power minus 2. I can write root of 20 into 10 power minus 4. I get root 20. Root 20 you may write it as into 10 power minus 2. This is the alpha. So, suppose if it is 10 power minus 3, what is going to happen? If the same thing on dilution 10 times, 10 power minus 3 molar, what about the alpha? Same logic. Look at this. Alpha is equal to root of 2 into 10 power minus 5 by 10 power minus, what is that? 3 cancelled off. Therefore, alpha is equal to root of 2 into, you can say 10 power minus 2. So, root 2 into what? 10 power minus 1. Look at this. Look at the 10 power minus 3 molar, 10 power minus 2 molar. Alpha is what? Increases, but Ka remains constant. This is what examination point of view they will ask you. Right or not? Is that no? Now come to the point. Now I want to clean this. Now what about in the case of, please keep it in mind. Same thing in the case of weak base. That means I'm taking as NH4OH in aqueous. We can say that as NH4 plus aqueous plus what is that? OH minus 1 aqueous. Now we can same logic, same thing. We get Kb which is equal to C alpha square. Therefore alpha is equal to root of Kb by C. Same logic only. Right? Because why Kb it's a base dissociation constant. Base dissociation constant. Now we can write that as POH is equal to 1 by 2 pKb minus log C. And one more thing, please keep it in your mind. We can write that Ka into Kb is equal to Kw. This is only for conjugate acid and base. K into Kb is equal to Kw at 25 degrees Celsius. At 25 degrees Celsius, K into Kb is equal to Kw at 25 degrees Celsius. This is only for conjugate acid and conjugate base. Now next come to the point. Now, buffer solution. This is what buffer solution. Then there are two buffer solutions. We can say that one is acidic buffer or basic. What is buffer solution? If you want to say, please keep it in your mind. Acid and conjugate base should be present in the solution. That's very important. Acid and conjugate base. Sir, what is acid and conjugate base means? They differed by one proton. Acid and conjugate base means they differed by one proton. So please, acidic buffer and basic buffer. See, when I'm going to add any buffer solution means what? If I'm going to add any acid or any base, strong acid or strong base, the pH of solution remains constant or the change in pH is what? Negligible. Now let us take the example. Look at this, I am writing acidic buffer. Acidic buffer. Let us take the example of weak acid CH3, C double bond O, OH. See, look at this. This is in solution. That means acid CH3CO minus is called what? The conjugate base of our acidic acid. So this is acid, this is conjugate base. The differed by is what? One proton. Now if I'm writing, look at this. CH3COOH. I can write it as CH3CO minus plus is what? H plus. Now I can write that CH3COO Na. It is strong electrolyte. CH3COO minus plus Na plus. Now if I write as Ka, I can write it as CH3COO minus and H plus by, I'm writing that CH3COOH. Please understand, this CH3COO minus, the contribution which is coming from only salt. Why here is called common ion effect. So due to the common ion effect, I have the more amount of undissociated acid. Therefore, this will have the more contribution than this. Due to what is common ion effect? In weak electrolyte, if we are going to add the strong electrolyte, the dissociation of weak electrolyte is suppressed due to the de Chatelet principle because of more concentration. So equilibrium go towards the backward direction. Therefore, I have the contribution of CaCO minus coming from that sodium acetate, not from the acidic acid. Are able to follow? So now, if I want to write as H plus is equal to, I am writing as H plus is equal to, I am writing Ka CH3COOH. I am writing as CH3COO minus this is nothing but salt. Now take the negative logarithm. Now I am going to get it as pH is equal to pKa plus log of salt by acid. This is called acidic buffer. What about the basic buffer? Same thing. You can take it as POH is equal to pKb plus log of salt by base. So now I want to give you the example of acidic buffer and example of what we can say basic buffer. This is the formula. Now look at this. Now please keep it in your mind. Buffer means what? Acid and conjugate base should be present in the solution. For acidic buffer, I am taking as NaCN, HCN. Acidic buffer and CC over H, and I can take it as a CH3, CO over Na. Now, what is basic buffer? Basic buffer. Look at this. Take it as a NH4OH, NH4Cl is called basic buffer. Even you can take with pyridine, can take as alright. Even we can take it as a NH4OH. So these are all the weak acid and strong, weak acid and base, strong base always gives what? Acidic buffer if the number of moles of base is limiting reagent. Look at this. Now I am taking CH3COOH plus NaOH. Now what is going to form? CH3COONA. Now if this is 1 mole, if I am taking this is 0.5 mole. What will happen? NaOH is limiting reagent. Therefore I can say this is 0.5 mole of acidic acid unreacted. This will be what? 0.5 mole of what is that form? Base, sorry, salt is formed, that means sodium acetate. That means this is conjugate base, this is acid. Acid and conjugate base present in the solution 0.5 mole and 0.5 mole. Therefore, this is going to act as a buffer. When acidic acid plus sodium hydroxide, if the sodium hydroxide is lesser amount, obviously that is going to form as a buffer. If 1 mole, if you are taking up to 0.9999 mole, solution is what? Buffer. Even if we take it is what? Look at this, CH3 COONA plus HCl. What is going to form as CH3 COOH? This also what? Act as a buffer. If the HCl is lesser amount than this, that means this is 1 mole. If I am taking is what? 0.4 mole I am taking. So it will be 0. How much is there? 0.6. Here is what? 0.4. Therefore, conjugate base and the acid exists in solution. The solution is called what? Buffer. So buffer means what? Acid and conjugate base should be present in the solution. This is one question now. Is it? I will give one question. I will give 2 questions. It is easy to understand. Now, in the exam, what they will ask you is today emails. They will give you as calculate the pH of I can say that 0.1 molar of 20 ml of H2SO4 is mixed with H2SO4 is mixed with 60 ml of 0.1 molar of ammonium hydroxide and pKb of NH4OH is 4.74. This was the question. So how we are going to answer this question? Look at this. Now, first write the equation. H2SO4 plus NH4OH. What you are going to get as NH4 twice SO4 plus 2H2O. This is the equation. Right? Now, 1 minute. Listen. Now, if I balance the equation, I am going to get 2. That means 1 mole is react with 2 mole. Now here, how many? 60 ml, 0.1 molar. That means 60 into 0.1, I am going to get is what? 6 millimole. Now here is what? 20 into 0.1. I can say that I made it. Sorry, children. and reverse. Plus this is 1 mole, this is 2 mole, right only. Now ammonium hydroxide is 60 into 0.1, I can write that 60 millimole. This will be 20 into 0.1, I can say is what? 2 millimole. Listen carefully, this question is very important. Now obviously what? 1 mole react 2 mole, so 2 millimole react 4 millimole. 2 millimole react is what? 4 millimole. Obviously I can say that this will be what? 0. Now here also I can write 0. Now this will be 0. Here what? 2 millimole is unreacted. So 1 mole is going to give 1 mole. Therefore you can say 2 millimole is going to give here is what? As 2 millimole only. 1 mole is going to give 2 mole. Therefore 2 millimole is going to give is what? Here also as 2 millimole of NH4 twice SO4 is formed. Please understand. It's very, very important. You have 2 millimole. Here also you have 2 millimole. We know that 1 mole is going to give 2 mole of NH4 plus. 1 mole which is going to give is what? 2 moles of NH4 plus. Now the 2 millimole is going to give is what? 4 millimole of NH4 plus. That means they're asking as pH. This is the basic buffer. We can write it as POH is equal to pKb plus log of salt by base. What is pKb is given? 4.74 plus log of. Anyway, here volume doesn't matter because we have the ratio N by V. So volume is not doesn't matter for the buffer. Now how many moles? 4 millimole, 2 millimole. I can write it as 4 by 2. I can take it as 4.74 plus log 2. Therefore 4.7 plus 0.3. So approximately I can write 5.04 as POH. Then pH is what? Approximately I can take it as 14 minus 5 is equal to 9. POH is approximately 5 I am taking, and pH is what? 9. This is what you may expect in JEE mains. Look at the logic, how I have done it. This is what the buffer. This is what we can say. This is what in buffer they may ask the question. Now next one, listen. Next we will go with that. Hydrolysis of salt. What is hydrolysis of salt? Salt is completely what we can say. It's react with water. That means in that there are, I am going to take as CH3COO and making is one as NH4Cl and NH4, that means I write it as CH3COO NH4. Listen to me. It's a combination of weak acid, strong base. It's a combination of weak base and strong acid. This is combination of a weak acid and its weak base. So how to find out the pH of this? We can say pH is greater than 7. pH is less than 7. In this case, pH is depends on Ka and Kb value. We can derive. I can derive one thing. Remaining, I'll give the formula. Look at this. I'm going to derive that as listen. CH3COONA. When water, if we do that, we are getting it as what? CH3COOH plus what is that? OH minus plus N plus. That means the OH minus ion which is coming from water. Now look at this. Now I can write K which is equal to CH3COOH. I can write as OH minus. By I am writing as what? CH3COO minus. This is called KH. KH is called hydrolysis constant. Now anyway we know that Ka is equal to I write as CH3COO minus and H plus by, if I am going to take as CH3COOH. If I am going to take KH into Ka, and I multiply this, cancel off. Yeah, OH minus N and H plus N is called Kw. You can write that KH is equal to Kw by Ka. Now the next one, same logic. The how much of salt is hydrolyzed with water. The how much is react and how much is unreacted at equilibrium I want to find. We know that KH equal to Kw by Ka. Look at that. Now I want to know that how much of this reacted. Same logic. When time is equal to 0, this will be C. This is also 0 and 0 I am taking. This is C minus CH, hydrolysis. Therefore, this is CH. This is also what CH. Now I can write KH. I can write C square, H squared by C into 1 minus H. Cancelled off. Assume that the 1 minus H is the less than unity. Therefore, C squared extends out. Can take C H squared is equal to what is Kw? What is KH? Kw by Ka. Therefore, H squared is equal to Kw by Ka includes what? C. Therefore, H is equal to root of Kw Ka into C. This is called degree of hydrolysis for combination of weak acid and strong base. Now multiplying the concentration of C both the sides. Therefore, CH is equal to OH minus, and right, CH is equal to root of Kw into C by Ka. What is OH? CH is what? OH minus N concentration is equal to root of Kw into C by Ka. Now I am writing that OH minus, how I am going to write it as Kw by H plus is equal to root of Kw C by what is that Ka. Now if I am taking this side, I can take it as what? H plus is equal to root of Kw into Ka by C is what? H plus N concentration. Take the negative logarithm of both the sides, you will get it as pH is equal to 1 by 2 pKa plus pKw plus log C. Please keep in your mind, in this the combination of weak acid strong base on dilution, pH will change, pKa and pKw remains constant because the equilibrium constant. So what about in the case of weak base and strong acid? Look at that. I'll write it one by one. Now I'm taking the CH3COONA. And the combination of weak acid plus strong base, and write pH is equal to 1 by 2 pKw plus pKa plus log C. What about the combination of, for example, I am taking NH4Cl, I am taking combination of weak base plus strong acid. You can say that pH is equal to 1 by 2 pKw minus pKb minus log C. Now if I am going to take as CH3COONH4 plus ammonium acetate, combination of weak acid and weak base. Now pH is equal to 1 by 2 pKw minus plus pKa minus pKb. You can take it. This is the formula. So this is, that means combination of weak acid and weak base. On dilution, pH remains same. Why? Because there is no concentration term is involved here. Therefore, the combination of weak acid and weak base is not depends on what we can say the concentration of the salt. It's independent of concentration of salt. On dilution, nothing is going to happen. pH remains constant. But here, dilution, the pH may change because you have the concentration term involved in the equation. And here we can say when pKa minus pKb, I told you that the combination of weak acid and weak base, the pH is depends on Ka and Kb value. If Ka greater than Kb, the pH is less than 7. If Ka less than Kb, we can say pH is greater than 7. I'll discuss one question and tell you that. It's very, I'll tell you that. Listen. Listen carefully. Now, I am taking calculate the pH of, that is 100 ml of 0.1 molar CH3COOH mixed with 100 ml of 0.1 molar 100 ml of 0.1 molar acetic acid mixed with 100 ml of 0.1 molar sodium hydroxide at 25 degrees Celsius. So the pKa of CH3COOH is 4.74. Neither is given. So how to solve this question? Now I am writing CH3COOH plus NaOH, which gives us CH3COO again. Now 100 ml of 0.1. I can write 100 into is what? 0.1. 10 millimole. This also is what? 100 into 0.1. This also is what? 10 millimole. 0. Obviously what? 1 mole react with 1 mole, produce 1 mole. 10 millimole. 10 millimole. Obviously what is going to form as? 10 millimole is formed. 10 millimole is formed. So there is no, this is going to what we can say, salt is formed, the salt undergone hydrolysis, but this cannot act as a buffer. Why? You don't have the acid is not exist in solution. Therefore, this is going to form as a combination of weak acid and strong base as salt is undergone hydrolysis. I want to find out the concentration of salt. Therefore, 10 by 200. So we cancel off 1 by 20. I can write that 1 by 2 into 10 power minus 1. Therefore, we can write that 5 into 10 power minus 2. Is the concentration of salt. Now what is the pH? Now look at this. I will go with that. Listen. So now I got the idea. Now pH. I write that 1 by 2 pKw plus pKa plus log C. Now what is 1 by 2? pKw is what? 14 plus pKa is what? 4.74. This is plus log of 5 in 10 power minus 2. So what is log 5? Log 5 is 0.7. 2 minus 0.7 is what? Minus 2 plus 0.7. We can say as 0.7 means as 1.3. Therefore 1 by 2, 14, 18.74 minus is what? 1.3. Now if I simplify this, I can take it as 18.74, 1.30. Therefore 4. I can take this also 7, this also is what? 4. This will be is what? 7. This will be is what? 1. And write 17.44 by 2. That means we can say that 8 remaining 1, 7. So the pH of solution is what? As 8.72. This is one way. But in the one more question what they will ask you, what is the pH of? Look at this. See. I will give you as calculate pH of 0.1 molar of NH4Cl. They will give you that pKb of NH4OH is 4.74. They are asking calculate pH. This is what? The combination of weak base and strong acid. So what is that? You can write that pH is equal to 1 by 2 pKw minus pKb and minus log C. Look at this. 1 by 2, 14 minus 4.74. Log C is what? 0.1, therefore plus 1. Therefore we can say that 1 by 2, 14 minus 15. 15 minus, I'll go with that. 14 minus what we can say 4.74. The 6 will be there, here 2 will be there, here what we can say as 3, 9.26. So 9.26 plus 1 we can write 0.26. Therefore we can write 1.26 by 2. Let's say 5.13. pH is less than 7. When pH is less than 7, it's acidic salt. And what about same logic? Look at this. Look at that. Now calculate the pH of calculate the pH of look at this, and I'm taking as 50 ml of 0.1 molar formic acid plus 50 ml of 0.1 molar of formic acid and ammonium hydroxide. Now pKa of this will be pKa of HCO over HS 3.74. Here is what pKb of NH4 over HS 4.74. Now anyway, this is weak acid and weak base. Concentration doesn't matter. Look at this. pH 1 by 2. You can say that as pKw plus pKa minus pKa. Look at this. 1 by 2. Now 14 plus 3.74 minus 4.74. 1 by 2. You can say minus 1, 13. Therefore 6.2. Look at this. Therefore pKa less than what we can say pKb. That means Ka greater than Kb. So obviously what will happen that pH is what? Less than 7. Therefore acidic. This is a combination of weak acid, weak base. So these type of what we can say questions you may expect in the what we can say JEE mains point of. Now come to the point of solubility product. Look at this case of solubility. What we can say as it's saturated solution, you can go for sparingly soluble salt. Now I'm writing that as take the example of look at this AgCl is a solid. Now when dissolved in water, obviously you have it as Ag plus as aqueous, I can say is what? Cl minus also is in aqueous. Now the question mark which I want to say here, please keep it in your mind. There is a dynamic equilibrium between these ions and undissociated solid. Now I can take it as K, which is equal to concentration of Ag plus and what concentration of Cl minus ion. Now I can write that Ksp which is equal to concentration of is what? Ag plus and concentration of Cl minus ion. Now I can able to find out the solubility of the salts also. When we know that at T is equal to 0 and T at equilibrium, I am keeping the solubility of Ag plus is yes and solubility of Cl minus ion is yes molar. And you give me this is yes, this also is what yes. Therefore I can say that Ksp which is equal to S into S. Therefore I can write that is what S square. Therefore S is equal to root of Ksp. So if we know the Ksp value, I can able to find out the solid. For example, AgCl, Ksp is what? 10 power minus 10. What is a yes? 10 power minus 5 molar. That means 10 power minus 5 mole is dissolved in what we can say 1 liter of solution. Right? Suppose they are asking, what about the Ksp of? They are asking like this. Can you relate between Ksp and solubility? I will take the example of SrF2. What is SrF2? we can write as SR2 plus 2F minus. Now this is S, this will be what 2S. Therefore, we can write KSP is equal to concentration of SR2 plus concentration of is what F2 minus whole square. So what is solubility SR2 plus S? This will be what 2S whole square. Therefore, 4S3 is equal to KSP. What about aluminium sulfide? We can take it. Let us take Al2 SO4 thrice is going to come as a what? 2 Al3 plus 3 SO4 2 minus. We can take 2S and 3S. Take KSP is equal to, we can write as Al3 plus whole square. We can take as here SO4 2 minus whole cube. Therefore, 2S whole square, 3S whole cube, 4S square into 27S power 3, beginning is 108 S power 5 is KSP. This is what you can relate that. But in exam, what they will ask you based on the common ion effect. So what will happen for in sparingly soluble salt? If the common ion is present, what about the solubility? I'm telling the solubility of salt is decreases presence of common ion. Take the example. I'm asking the question. Look at this. I'll explain. Then I'll give you a question. You are going to find out. Look at that. The question is AgCl. Okay, they are telling that KSP is what? 10 power minus 10 at 25 degrees Celsius. So find the solubility of what we can say water and find the solubility of 0.1 molar NaCl. Look at this sodium chloride. Find the solubility of AgCl in water. How I can write? Yes, definitely Ag plus Cl minus ion. Therefore, this is yes. Yes, I can write that KSP is equal to S square. Therefore, S is equal to root of KSP is what? 10 power minus 10. Therefore, 10 power minus 5 is solubility of AgCl in water. Now, what is solubility of AgCl in 1.1 molar of NaCl? Look at this. Now, AgCl. Now, obviously, is what? Ag plus is what? Cl minus. Even NaCl is strong electrolyte, dissociate completely. Therefore, I can write that NaCl, which gives us Na plus what? Cl minus ion. What is concentration? This will be 0.1. This is yes. This is yes. What is total will be is what? S plus 0.1. Now I can write that KSP. So due to the common ion, KSP value remains constant only because KSP depends on temperature. Therefore, I can write that Ag plus Cl minus. Now what is Ag plus will be I am giving as a S. What about Cl minus? S plus 0.1. See, in water itself 10 power minus 5 S. Due to the common ion effect, the equilibrium go towards the backward direction. That means solubility of salt is what decreases. So therefore, we can neglect as compared to 0.1, you can neglect this solubility. Therefore, Kc is what? 10 power minus 10. Therefore, S is equal to 10 power minus 10 by 0.1. Therefore, S you are getting 10 power minus 9. Look at this, in water 10 power minus 5, the presence of the common ion 10 power minus 9. So which means that what? The solubility of salt is decreases due to common ion effect. That means that whatever the Cl minus ion coming from AgCl is neglected as compared to whatever coming from the Cl minus ion. That's all. Now, one question to discuss what they are asking the JEE mains point of view. Look at that. So the question is, calculate solubility of BbI2 in 0.1 molar Ki solution. Ki solution is a question. Now, KSP of BbI2. KSP of BbI2 is nothing but 4 into 10 power minus. Now, adding BbI2 is going to give is what? Bb2 plus is what? 2I minus Now Ka is what? Strong electrolyte, which gives concentration as K plus what? A minus ion. What is concentration is given? 0.1. This is what? 2s. This is S. So what is total concentration of I minus ion? 2s plus 0.1. Right, the KSP. KSP is equal to, we can take it as a concentration of Bb2 plus, and is what? I minus square. Therefore S into what? S plus 0.1 whole square. What is KSP? 4 into 10 power minus 10. Now, so as compared to what we can say 0.1, this S can be neglected. Therefore S is equal to 4 into 10 power minus 10 by cancel off. We will get the answer of. That's all. This is what you may expect in what we can say that JEE mains type of question. These type of questions expect. Even there is a condition is there. What is the condition? They may say that prediction of what we can say whether the precipitation takes place or not. What they will say, if it is KSP less than KIP, precipitation occur. When KSP greater than KIP, no precipitation occurs. If it is KSP is equal to KIP, we can say precipitation is going to begin the precipitate, it's going to be start. That's all. So based on this, what JEE mains will ask you, look at this. Calculate what pH at what minimum pH MgOH twice at what minimum pH, so the magnesium hydroxide get precipitate at concentration of Mg2 plus is 0.01 molar. I can say that KSP of MgOH twice 4, I can go with that 10 power minus 12 molar. See, at what minimum pH MgOH twice should get precipitated? At the concentration of the Mg2 plus ion is what? 0.1 molar. This is what they are given. So very simple. You can go with that. What is minimum? That means minimum pH to precipitate. That means what? Begin to precipitate means what we can say as KIP is equal to what? KSP. So now I can write that KSP is equal to, I can write that Mg2 plus, I can write that what? OH minus square. Now what is KSP is 10 power minus 12. Mg2 plus what? 10 power minus 2. This is what? OH minus square. So I can write OH minus is what? 10 power minus 5. Therefore, POH is equal to 5 and pH is what? Is 9. This is what we can say as the JEE mains point of view. You may expect that. And next one. I want to give you one question. Now, find out the solubility of, last question. Find the solubility of AlOH thrice N. Find the solubility of aluminum hydroxide in 2 molar of NaOH. 2 molar of NaOH. And 2 molar of NaOH means what? Because there's, I can write KSP, I can take it as 4 into, I mean approximate 10 power minus 120. Just for write like this. Okay. Now, and write that AlOH thrice we have is what? Al 3 plus 3 OH minus. Now NaOH is nothing but Na plus OH minus. This is what? 2. Total is what? s plus 2. That means 3s plus 2. Therefore, Ksp is what? 4 into 10 power minus 20 is equal to Al3 plus is s. This is what? 3s plus 2 whole power cube. 3s can neglected. So I can write 2 cube is what? 8. So 4 into 10 power minus 20 by 8 is equal to s. Therefore, 1 by 2. 1 by 2 means what? 0.5. Therefore, I can say that s is equal to 5 into 10 power minus 20. Right? So, you may expect such questions for what we can say the JEE mains. So, we have completed ionic equilibrium. So, chemical equilibrium is over. So, start practice the problem. So, it's more effective. And the next class we'll start kinetics and solution. And study well. All the best. Thank you, children.